Now we are getting into properties of quadrilaters. We will not be able to say what this quadrilateral is until we get its properties. We've got a tracing paper here, or we have got this quadrilateral ABCD. Okay. Now we are going to place a tracing paper on the quadrilateral and trace it. And then I trace it for the sake of time. I trace it before and okay, compare and trace it. This is done. Compare opposite sides and thereafter opposite angles of the quadrilateral after 180 degrees rotation. So what I'm going to do, I'm going to mark this angle and I'm going to mark this side. Okay, I will mark it on paper. Okay, I didn't trace it, but I simply marked. So I also try to trace the angle, although not the names of angle A, B, C, D, which are on paper, but not to be accurate, the letters, only letters. So what we're going to do is to place this pen at the center. Center of both. Look at that dot. Okay. Look at that red dot and that marking on AB, where they are going to land after rotation. Okay. After rotation, where are they going to land? After 180 degrees rotation, where are they going to land? It is slipped. It is slipped. Have a look. Have a look. Where did it land? Okay, sorry. Where did it land? Have a look. Where did it land? Where did it land? Now you can see that this is marked, this is now marked. That marked, that marked. So we're able to see that this angle, this angle C, angle A on paper, angle A on paper is equals to angle C. This is where this is the C on the paper. This is the C on paper, and the A is on top of the C and fits well. It's an obtuse angle, and this one also obtuse angle. There, C is now on top of A. Here A is now on top of C, and the two angles fit in. So meaning that C, A, and C, angle A equals to angle C, and angle C is equals to angle A. Okay? So that's one thing that you're able to get. One other thing is that remember we had AB here on paper. After rotation, AB sits now on AC, and is exactly AB is exactly equal to CD. Even when it comes to this side, you can see CD is on exactly equals to AB. It's after rotation. That is what we're able to find out. So as you can see now here, this B on the 3 is equals to D. B is equals to D. Okay? And you can see this is AD and BC. The two sit on each other, and BC is exactly equals to AD. We could have marked it differently from this one. This one will come this way. Perhaps we could as well repeat it again and say this one and this one is also marked. This one is also marked. Is also marked. Okay. Is also marked. Now we hit. Look at this one. Look at this one. Look at AD, where it's going to sit. There it is. You can see that the two are equal. Ne? You can see that the two sides are equal. Okay. I think up to here, for opposite angles are equal. Angle B, I think we have already indicated that angle B is equal to angle D. And okay, so we proceed to the next activity. So what we are going to do is, in the next activity, we are going to trace the diagonals, what we call diagonals. Oh, this one had to be traced as different. We have to trace the diagonals. Let me use this one. Okay, trace the diagonals just like this, as accurate as possible. As accurate as possible. As accurate as possible. Now we are tracing the quadrilateral. Now we are done with the quadrilateral. We must trace the diagonals. Okay, this is A, this is V, this is C, this is D. Now we are also going to mark this. We want to see where, remember the intersect, that's the intersect. Okay, we are going to do rotation and try to compare AC and AC, AO and OC, and see what comes up. We'll shift a little bit so that, okay, now let's look at the marking. 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 Let's look at the marking of the diagonals. Let's look at the marking. Let's look at the marking. Now we have got AO on paper. Now we have got OC. AO on paper. AO on paper is equals to OC. Okay. AO on the transparency is equals to OC. Okay. You can see marking. Now BO on paper. BO on paper is equals to OD. And OD on paper is equals to BO. So it tells us the diagonals bisect, diagonals bisect each other. The diagonals bisect each other. Okay, the diagonals bisect each other. You can see this side and this side and that side. They bisect each other. One diagonal bisect the other, one diagonal the other. So in any way, if we are to come to issues of congruency, you can say this triangle is congruent to this, because this side is equal to that side and that side equals to this side. And we have done an included angle because of vertical opposite angles. The same applies to this, and they are congruent triangles. These are vertical opposite angles. This side is equal to that. Yeah. This side equals to that, and this side is equal to that. Okay. Yeah. Thank you. I hope you've enjoyed. Keep watching my videos. Subscribe to my channels. Thank you. And don't forget, this type of a quadrilateral where opposite angles are equal and opposite sides are equal and diagonals bisect each other is called a parallelogram. And they are not only equal. Ne? The opposite sides are not only equal, they are also parallel. Okay, one thing that you shouldn't forget, the properties of a parallelogram: opposite sides are also parallel, opposite angles are also equal, a pair of opposite angles are equal, and the diagonals bisect each other. Thank you very much. Keep watching. Subscribe to my channel.